Hey, problem solvers, Colfax Math here. Today I was going to go over a medical math exam. This is actually from Skills USA. Let's go over some of the big ideas. This would be a great practice exam if you want to become a medical assistant, go into nursing, and go into medicine later on. Kind of an entry-level exam, mostly on unit conversions and figuring out dosages. By no means am I a medical professional. I actually teach high school woodshop and math, and I'm good at math. So this is really a math video for people who are looking at going into the medical profession. Let me put the camera over my shoulder and we'll get started. Okay, so here's the exam right here. I typed it up in a Google Doc, but I'll put a link to the exam in the description below. The link is to multiple choice exam. The actual exam will not be multiple choice. I would print it out and cut off all of the answers and cover them up and then try and figure them out that way. It's probably the best way to go. I would watch this video by pausing it, doing the problem yourself, and then maybe hit play and then watch how I solve it. And then pause it, do the problem yourself, and then play and then watch how I solve it. There are a couple conversions you need to know. The first conversion is that there's 2.2 pounds in a kilogram, and that's really just something you have to memorize. And 1 ounce is approximately equal to 30 milliliters. Also, let's see, we have a deca is 10, so a deciliter would be 1/10 of a liter. A centi would be 1/100th of a liter, and a milli is a thousandth of a liter. So let's take a look at problem number 1, and you'll understand this idea of multiplying by 1 if you see me do this. So I'm starting with 30 deciliters. That's going to be 30 deciliters over 1. I multiply it by a factor of 1, so that whatever's in the numerator, the top of the fraction, has the exact same weight as what's in the denominator, the bottom of the fraction. My units are the key here, so I'm going to put deciliters in the bottom. So deciliters go down below. Again, there are 10 deciliters to 1 liter. These two things are the exact same, so it's the same weight, so this is a factor of 1. My deciliters cancel, and then it gives me liters as an answer. And then I just do 30 times 1 divided by 10, or 3, and I get 3 liters. Problem number 2 here, how many liters is 120 milliliters? So I start with 120 milliliters. I want to end with liters as well. Milli is 1,000, so there's 1,000 milliliters in 1 liter. These are the same thing. This whole thing's a factor of 1. My milliliters will cancel, leaving me with liters. That's what I want. 120 over 1,000. One of those zeros will cancel, giving me 12 over 100. 12 and 100 is 12%, or 0.12 liters. Number 3, again, pause it, do the problem first, and then watch my solution. So number 3, you have an object of 65 kilograms. You write that down. What is the object's weight in pounds? I'm going to multiply by a factor of 1 and end up with pounds. So I know kilograms go down here, pounds go up here, and I know that because I want these kilograms to cancel and give me pounds. So I know that 2.2 pounds is equal to 1 kilogram. And then my units cancel, and that's going to give me pounds like I want. So 2.2 is surprisingly easy to multiply by 65. So I'm just going to multiply that 65 by 2 to get 130. And then that 0.2 times 65 will give me 13. So I'm going to have the sum of that 130 and 13 to give me 143. So the conversion of 65 kilograms to pounds is 143 pounds. The next problem is the exact same thing. Now, Mr. Jones weighs 85 kilograms. How many does he weigh in household measure? I think that must be pounds. I never heard that expression. Same conversion, 2.2 pounds per kilogram. That's going to give me pounds here. And my kilograms are going to cancel. So I can see I have my units right. And I just do 85 times 2 would be 170. 85 times 0.2 is the same thing, 1 decimal place over, 17. Add them together to get 187 pounds. So you could see, so far, all these problems are really just unit conversion problems. All right, next, number 5, you are asked to administer 30 milligrams, so I'm going to write that down, 30 milligrams of a medication that is supplied in a 10 milliliter vial containing 100 milligrams. So I'm going to multiply that by 10 milliliters over 100 milligrams. Right, these are in the same unit, different units but same container. And it's asking you how many milliliters I need. So the fact that they're asking me for milliliters is letting me know that the milliliters go in the numerator, milligrams go in the denominator. My milligrams will cancel. That's going to give me the milliliters that I wanted. And then now I do my canceling. 30 times 10, 300, divided by 100 is 3 milliliters. You got to keep track of the units. That's what this is all about. Okay, number 6, you are preparing 250 milligrams of whatever that is, Dobutrex, in 1,000 milliliters. So this is what I have here. So I have 1,000 milliliters and 250 milligrams of 0.9 solution, saline solution. I don't even know if I need that 0.9% saline solution. It's a bit of a distractor. To infuse 0.22 milligrams per minute. The GTT, that's shorthand for drops per milliliter. So I have my 1,000 milliliters per 250 milligrams. I have 0.22 milligrams per minute. I'm multiplying those together. And the GTT factor is 15 GTTs per milliliter. You will adjust the IV flow to. So how many drops are you going to want? So you want GTTs. So the GTT factor is 15 drops or GTTs per milliliter. And then round to the nearest droplet, GTT. So let's see if all these things are going to cancel out. So I have milliliters are going to cancel. Milligrams cancel. And then that's going to give me a flow rate of drops per minute. And that's what I was looking for. 1,000 divided by 250 gives me that 4 times 0.22 times 15. And that'll be my units of GTT per minute. So I need to go 4 times 0.22 would be 0.88. 0.88 times 15. This will be 40, 44. 8, running out of room, 8. And then that's going to add up to a 0, a 12, carry the 1 at 13. And then I have 2 decimal places over. So it'll be 13.2 GTTs per minute. Round to the nearest GTT, so it wants to the nearest droplet per minute. So I'm going to round down to 13. So my answer here is 13 GTTs per minute. All right, let's turn the page and move on here. Number 7. And again, I've said this before, but I go ahead and do the problem first with the video paused, and then make sure you have the right answer, and then check it against mine and see how it's going. The physician orders 0.3 milligrams per kilogram of a specific drug for a 67 kilogram patient. How many milliliters contain the prescribed dose of the vial? 1 milliliter equals 10 milligrams. So we know that we're going to have to put 1 milliliter in the numerator, 10 milligrams in the denominator. And I know that because I'm trying to get rid of these milligrams and end with milliliters. So my kilograms will cancel. This will be over 1. And I think that's it. And that's what I'm looking for is milliliters. So I do this times this times this. So 0.3 times 67. I'll just do this on a calculator. So 0.3 times 67 divided by 10, and that's going to give me 2.01, and it says round to the nearest tenth. So I take that 2.01 and round it down to 2.0, or just 2. And most importantly, don't forget those units there, so I'm at 2 milliliters. Number 8, in a 24-hour period, Miss Weekly drank 6 ounces of orange juice, 400 milliliters of water, and the pint of milk. 16 ounces to the pint. Again, you just have to know that conversion, kind of crazy U.S. system, but it is what we have. What was her total 24-hour intake? So we're really just going to sum up all of these liquid units. So we have 400 milliliters. We have 6 ounces, remembering that 1 ounce is 30 milliliters. So I would convert that by multiplying it. 30 milliliters is 1 ounce. My ounces cancel, so that would give me 180 milliliters. 6 times 3 is 18. And then the 0, 180 milliliters. 16 ounces, right here converted to milliliters, 30 milliliters to the ounce. Ounces cancel, that'll give me milliliters. I can't add these things unless they're all the same units. 16 times 30 is 300 plus 6 times 30, 480. So that's 480 milliliters. And then I'm going to add all 3 of those beverages up to get 0, 16, 10, 1060 milliliters. So there are units conversions, but they're not rate problems. Number 9, I have a vial of 2.5%. So we'll just call that 2.5 per 100. Contains 50 milliliters of a drug. I don't know if that's going to be relevant. What is the proportional strength of the solution? So this isn't actually part of the problem. What we're trying to do is we're trying to take this percentage and convert it into a proportion. So we're trying to figure this out as like 1 over a certain number. So I could do 0.5 goes into here 5 times, and 0.5 goes into here 200 times. So it's 5 to 100, but I could reduce that. 5 goes into 240 times, so it's a ratio of 1 to 40. So this is telling you a ratio of 2.5 to 100. That's what the percent's about. 50 milliliters is just the actual thing you're working with. And then you could reduce this a lot of ways, but you don't want a decimal and a fraction. So I could do 25 over 1,000 and reduce that, or I could say 0.5 will go into here 5 times and into here 200 times, and then reduce this fraction to 1 out of 40. Number 10, how many grams of a pure drug are needed to prepare 3,000 milliliters? So 3,000 milliliters at 2%. I convert that to a decimal 0.02. And I think I'm just multiplying those together. Yeah, so it's this percentage of this dosage of this solution. So I take 0.02 times 3,000, and that's still going to be milliliters because I'm this is only a percentage. 2 times 3 is 6, right? I'll do it this way, 3,000 times 0.02, and then I have to, that's going to give me 6,000, and then I have to remember the decimal place is over 2, so it's going to give me 60 grams. Number 11, how many grams of sodium chloride are needed to prepare 250 milliliters of 1%? So it's the same thing, 250 milliliters. I'm going to convert that percent to a decimal times 0.01. That's going to move the decimal place over 1, 2, over 1, 2, and that'll give me 2.5. And that'll actually be grams as well. Let's turn the page. Number 12, I have 0.25 grams of a substance. Add 10.4 milliliters of sterile water to a vial. That's just a distractor, resulting in 1 milliliter per 500 milligrams. So I'm going to end with 1 milliliter per 500 milligrams. How many milliliters? So I want to know how many milliliters will I need. So that's what I'm looking for. And what I'm going to do is put that 0.25 grams here. But before I do that, I'm going to take that 0.25 grams. And I know that 1,000 milligrams equal 1 gram. So these grams will cancel, give me milligrams, which is what I have down here. 0.25 times 1,000 would be 1, 2, 3, 250. So this is 250 milligrams. Let's do a little double check on this setup. The physician orders 0.25 grams, which is my 250 milligrams. The result is 1 milliliter per 500 milligrams. How many milliliters will I need for that 0.25 grams or 250 milligrams? So I could cross multiply this if I wanted to, or I could see that 250 times 2 is 500, or 500 divided by 2 is 250. 1 divided by 2 is a half, so this would be 0.5 milliliters. The ratio of 0.5 to 250 is equal to the ratio of 1 to 500. Okay, number 13, you're doing great. Keep going, we're almost done here. Patient must receive 150 milligrams of something. The bottle reads 50 milligrams per 5 milliliters. So this is a ratio of 1. These things are equal. So I could put 1 in the numerator, 1 in the denominator, and this whole thing will be equal to 1, so it won't affect the value. Which one goes where is kind of told to me by what units I want to cancel. How many ounces? Oh, so we got another conversion as well. So the milligrams, the 50 milligrams, go in the denominator so that these milligrams could cancel, and the 5 milliliters go in the numerator. So my units cancel. I'm now in milliliters, and then I need to go to ounces, and I know that there are 30 milliliters per ounce. So again, I'm going to multiply by 1. 30 milliliters equal 1 ounce. I know it goes that way so that my milliliters cancel and leaves me with ounces. So now I have 150 times 5 divided by 50 divided by 30. Right? So let me do that. I know 50 will go into here 1 time, into here 3 times. Then I have 3 times 5, 15. 15 divided by 30, so it'll be 15 over 30 ounces, or 1/2 of an ounce. Okay, last problem right here. If you like this channel, it's a practical math channel. Think about subscribing if you're new to it. And if you like this video, hit like. I'd really like to hear your comments below. And really, my big question is where you're going with medicine. Are you going to medical school and this is just an entry exam you're working on? Or if you're going to become a medical assistant, whatever it is, please write in the comments below. And the big ideas in the math here is really this idea of multiplying by factors of 1 to get the units you want. This is all called unit conversion. I love math, and I really like practical math and how you use it. Let's do this last problem here. How many grams, so I'm looking for grams of solute, are needed to prepare 2 ounces of 8% iodine? So that's going to be 0.08. That's just a conversion from percent to decimal. And then it's asking for grams and then ounces. So 1 gram of water is equal to 1 milliliter of water. And that's how the metric system works. So I know that I'm going to have to multiply here by 1 ounce in the denominator. So 1 ounce in the denominator is approximately equal to 30 milliliters. Once I do that, my ounces will cancel. That's going to give me milliliters. There's no units attached to that percentage or decimal. And the milliliters are equivalent of a gram. So I have 2 times 0.08 times 30. I'll just do the 2 times 30 to get 60 times the 0.08, 0.48, and then I'm over 1,2 over 1,2. So I'm going to end with 4.8 milliliters or 4.8 grams, which is what I was asking for in grams. So again, thank you for watching. Love to hear your comments below. This is Colfax Math, the Practical Math channel.